Hello, everybody, and welcome back to the Math and Physics Podcast. I am your host, Parker.
And I'm Ray, and we welcome you to episode 19, where today we're going to be talking about some interesting stuff about what math could have been. Parker, care to explain it?
Yes. Before we actually get into the podcast, I just wanted to say a quick word on Spotify. We are up to 122 followers. So thank you, everybody who's been following us on Spotify. If you're listening right now on Spotify and you're not following us, please hit that follow button. You know, we want to make it out of these streets. In other news, we're almost at 2,000 downloads in total. So the podcast is still surviving, even though we're not sticking to the recording schedule. We're still staying afloat.
We're still very sorry for that. I think we apologized for it last time. Yeah. We said we wouldn't do it again.
Yeah, we did.
And then we end up doing it again. Yeah. So yeah, wasn't too great for our credibility, but won't happen again.
Hopefully. I mean, I'm just working and watching YouTube videos. True. And then every time I tell you let's record, it just the time passes.
It's also like you're always free at different times. Like I'm busy at night, you're free sometimes at night.
Yeah.
Because then you work and stuff like that. So it's a lot of differing schedules and stuff. Yeah. It's just hard to plan out sometimes. I don't know.
Yeah. So today we are actually going to be talking about alien math. And let me just explain what that means before we start talking. So the idea for this podcast is we're just going to have a conversation about I'll put it like this. For an advanced civilization to exist in this universe, I think it's fair to say that math is necessary. Would you say?
Math is, I think, very essential to existence.
Yeah.
Yeah, very much necessary.
Yeah. So if aliens were to exist on the level that humans are right now, they would definitely have math, some form of math. But because, the math that we know is isolated to the Earth we're on, and for all we know, it's isolated to the entire universe. But if we were to discover another alien civilization, they would have their own version of math. And it's just an interesting conversation to be had about what could be and how it could be. You know what I mean?
I mean, to be honest, I wouldn't even know where to start because, not being one of the founders of mathematics in this earth, I wouldn't really know where to begin, to be honest.
Well, here's one place we can start. Well, obviously, this is very, very subjective. But I think the natural numbers, 1, 2, 3, 4, and on, even though the odds that we have the same base, which we have base 10, so we count up to 9, and then it goes 1, 0, and then up to 99, and it goes 1, 0, 0. You just restart every multiple of 10 or whatever.
Mm-hmm.
Although we might not have the same base as an alien civilization, I do think that the natural numbers, just counting up in units, is definitely essential. It's the beginning of all math.
Mm-hmm. I think numbers would be pretty universal, to be honest. I'm not saying base 10, obviously. I'm just saying the concept of numbers themselves. Just something as simple as, 1 rock, 2 rocks, 3 rocks, stuff like that. It's very easy to be able to differentiate 2 from 1. Mm-hmm. So I think numbers are probably the first, thing to discover mathematics.
One thing that's pretty interesting, I saw this, I think it was a YouTube video, but I saw somebody arguing why base 12 would be better than base 10.
I think I have also seen this video.
Yeah, I think it's a number file video too. Sure but basically, instead of counting on your fingers, you look at your 4 fingers, excluding your thumb, and then you count
your ridges.
Not the ridges,
not the
each finger has 3 subdivisions, I guess. like
yeah,
your knuckles divide.
That's what I meant when I said
yeah.
ridges. Sorry.
And basically, you'll see that, well, you have 12 of them. So basically, you can count the nubs of your fingers, if you, like, for kids when they learn to count. And the reason why it's better than base 10 is because 12 has more prime factors, right? There's 1, 2, and 3. And that's a lot better than 10, because 10 has 1 and 2. And by adding that prime factor, it makes it actually a lot easier to perform mental math, and therefore kids would be better at math earlier on in their development. It went something like that.
Yeah, but I just think in general, base 12 would be pretty cool. It would be really confusing at first, for sure.
Yeah, it would.
But I think it will be really cool. But I really don't think it's going to be changing, at least for us.
No, definitely not.
Yeah, I don't think it's going to be changing, but there's definitely possibility that, there's another base or something that exists somewhere else in the universe where they don't necessarily have to have base 10. I think that's very much possible.
Yeah, definitely. Well, there's groups of people on Earth that have different bases. Like, I know there's like an uncontacted tribe or something like that. Like in what's it called? Mesoamerica, something like that.
Mm-hmm.
And basically they have like base 28, and yeah, they just, I don't know, that's just how they do it, I guess. There's not really
base 28 is crazy.
Yeah. And
what,
like,
in the world?
And yeah, I forget how, but like they count kind of like the joints between like their fingers all the way to their shoulders, and then down to the other arm, like every like connection point, there's 28 of them. I don't know. Anyways, the point of this is that base 12 is easier to learn multiplication and easier to learn division, because it divides easier.
Mm-hmm.
Yeah.
1 minute, I was thinking about something that you said earlier.
Yeah.
Aren't the prime factors of you said prime factors of 10 are 1 and 2?
Yeah.
Isn't it like 5 as well?
Oh, true. Yeah.
So if we're counting 1, that would make it 3, and base 12, if we're also counting 1, wouldn't that have 3 as well?
I'm not sure what I meant by that.
Interesting. Did I just break the entire math system?
Yeah, possibly.
I'm kidding.
Yeah, no, you're definitely right, but I'm not sure what I meant by that. But again,
there's definitely a reason, though. No,
there is
I
a
have
reason.
seen the video and I know what you're talking about. I just forgot the reason as well.
Yeah.
Like there is a reason though why like it could be of better use, and it just makes math a lot not easier necessarily, at least as of now, but it makes it better to learn.
It makes it more fluid. Like even though base 10 feels supernatural to everybody, well, not everybody.
At this point,
but,
obviously.
Yeah, at this point.
I mean, at this point, I think, literally everyone, I don't think there's a single soul on the earth, but literally everyone has been brought up with base 10, and everyone knows, the 10 times table. It's so easy.
Yeah.
So I think to change that would be very impossible.
Yeah, in my head, though, base 12 does feel like, it feels like an upgrade, Something like that.
I mean, I guess it could, yeah, because, any bigger number seems like a better number, right?
For the next podcast, I'm going to watch that video about base 12, and I'm going to give you the exact reasons why. Because this is just, something I remembered. I don't memorize everything I watch, but yeah. Moving on from, the natural numbers, things get a little bit more complicated when you start adding operations. Like addition, subtraction, multiplication, division. One thing that I would like to argue is that the basic operations that we have, if you're using, let's say the alien civilization found the natural numbers, which I think is very natural, no pun intended, but they figure out the natural numbers.
Yeah.
And they're counting all day long. Next thing you know, right, I think it's pretty obvious that after you start counting things, adding and subtracting is the obvious next step, because you see that when you're counting, you're actually just adding 1, right?
Basically.
You're just adding 1 every time. And then let's say some alien is like, hey, I have 2 rocks in this spaceship. We're not at that point yet.
Yeah, exactly. I don't think we're at the spaceship point yet. If we're still figuring out math.
I have 2 rocks in this bowl.
Okay.
And I have 2 rocks in that other bowl.
Mm-hmm.
In total, I have 4 rocks.
Oh, no. What? How did you find that out?
Performing addition just feels like it goes hand in hand with just numbers in general. Yeah. Just having numbers. Am I wrong?
I think no. I think you're very much correct. I think addition, subtraction, I think all of the basic, or again, this is all subjective. And when I say subjective, I mean this is all subjective to humanity, like the human race. Because we literally have no other idea what else is there other than addition, subtraction, multiplication, division, you know?
Yeah, literally.
Like, to be honest, I mean, it's very unlikely, but who knows? There could be a whole new form, a whole new operator that we had no idea about.
That's what I'm saying.
That, like, we still have yet to discover. Something very simple, so yet something we don't know. I don't know. There's so many possibilities.
It feels so unlikely that is.
Yeah, because I think we've pretty much covered all the bases. Like, I mean, what else is there? You can take something away, or you can add it. Right?
Right.
I mean, there's not much more you can do.
Like, without getting into complicated stuff, where, like, in calculus, I think, like, the idea of limits and derivatives and integrals, I think in an advanced civilization, those ideas would still carry over. The only thing that would make it significantly different is the notation. That's it.
Mm-hmm.
Like, we have a squiggly line to determine an integral, and then they might have I don't know, like, okay, yeah, like, whatever. I mean, we doesn't matter.
Really suppose that, to be honest. Who in the world knows what alien math would look like?
Yeah.
But I guess if you're saying, will they be able to discover it? I mean, I think it's very much possible. It's a very much discoverable thing. I mean, we did it, and we're pretty stupid as of this point.
Yeah, you know, so but if you think about it,
sorry,
like, if you take a moment to think about it, like, if you go step by step of, like, what comes after the last, or what comes next, you start with numbers, because, you know, what else are you going to start with? You can't start with integrals.
That's true.
You got to start from the very beginning. This is when we're, like, primates or whatever, and we're just. We're a group of monkeys, and they say, okay, we are 5 monkeys, like, right there. You guys are counting already. 5 monkeys sitting around a
log. We're like, 1 stone plus 2 stones.
Yeah. So numbers is the obvious starting point for math, because it's just made so that you can't really do it without numbers. I don't know. Do I need to explain that?
Yeah, no, I think that's pretty self-explanatory. I think math does require numbers. But, I mean, ironically, you know, at an older age, math kind of separates from numbers and starts becoming more about letters and stuff, you know, with variables and stuff like that. That's probably also discovered later on.
Yeah, the thing about numbers is that once you know how to do once you know how to manipulate small numbers, it's the exact same thing with big numbers.
The
like, nothing
operation
changes.
is the same. It's just that the computation might take longer.
Yeah, exactly. You know? So then you get into the thought of, you know, what happens when I try to do this operation with a number that I can't even imagine how big it is, or I can't even imagine how small it is.
Well, I don't think that's the first starting point of variables. I think the first starting point of variables is
obviously
like,
not.
I think the first starting point is like where they're, hey, what if instead of this number we took any number? What if this can be any number in the number system? I think that's a more probable way of starting, no?
I disagree, actually.
You don't think so?
No, I think variables, well, if you actually think about it, variables are just used to find an answer. Like, let's say 5 is equal to x plus 2. What you're really asking is, what number minus 2 equals 5? Like, it's just kind of a placeholder for like a question mark. You're saying...
No, but again, that's not really the discovering part. That's more like when we already know that variables exist, we can put a placeholder to find out what the answer can be. I'm saying, like, how do you think variables came into place? Like, what do you think people thought of when they're like, hey, why don't we put a letter instead of a number? Like, you think that they were trying to find something out that they already knew when they were trying to do this? I don't know. Like, that's what I was saying.
To be honest, like, I don't know. Like, there's not really a way to know how it all started.
I mean, there's no real way. That's why I'm just asking you, like, what do you think?
Maybe someone was like, okay, let's, like, maybe they were trying to do, like, a game. It was like, okay, I'm gonna write down x equals 5. And then I'm gonna add 2 to both sides of that
This is
equation.
how you think they came up with variables?
No, just think about just think about this. Say okay, x is equal to 5. I'm gonna add 2 to both sides. So now I have 2 plus x is equal to 7. And then he went to his friend and he's like, hey man, try to find x. And the guy's like, what is x? It's not a number. He's like, man, it's any number. You just gotta tell me what it is. And then boom, you got variables.
Yeah, I don't really know if that's how it went down. It probably went down something like this. They were probably like, hey, listen, right? So I'm trying to get 5, like maybe they were like, okay, 10 plus 3 is 13, right? They're like, okay, that's dope. But what if I change the 3 to any number? 5 plus any number. What would that be? Right? And then maybe that's how they came up with the idea of a variable. Like, what would 5 plus any number be? Would it be one answer? Obviously not, right? Obviously not.
Yeah.
But that's maybe how they came up with the idea. That what if we have this one letter, this one variable that can be any number? You know? Because that's also kind of how functions work, right? Like where x can be any number. And that's the entire point of a function, right? Where you can take literally any point on the x-axis and you'll find a corresponding y value, right? So maybe it could be that's how the aliens will discover variables. Who knows? Who knows?
They're just having a casual conversation about the one problem I have with this, and I think you have the same problem, is that this is all like banking on the fact that they're using numbers to start with, you know?
I mean, what else would they use? Do you think they would start with variables?
I don't know. Like, what? Like, we don't have a way.
I mean, even if they use letters, that doesn't change. I mean, as long as they don't use variables to start.
Because our brains are so, like, deeply ingrained into the system that we have now that we can't even imagine. But, like, it just seems like the only way. Also, one thing I wanted to bring up is that, like, I think linear algebra is so solid. There's not really a way to get the answers you want. I don't really know what I'm trying to say right now.
Okay, maybe I'll just cut you off. But the real question is there any other way to get to the same answer that maybe we have no idea? Because, see, our foundation was built on how we discovered all of these things, right? Now, if another civilization in another universe, in another galaxy or whatever, right, discovers the same thing, there's a very high chance that they discovered in a completely different way, right? We've already agreed on this. Like, so if their foundation is just completely different, but, I mean, maybe not completely different, but if their foundation itself is different from ours, I don't see how their linear algebra or anything would...
I guess.
I mean, it would behave the same way because obviously math doesn't change in the universe anywhere. It would behave the same way, obviously. But I don't think it would be like... I don't know how to say it. I don't know how to say what I'm thinking.
My opinion is that the ideas would be exactly the same. Like the ideas that we have in math,
Yeah, but the
like taking
implementation will be
derivatives.
different.
Yeah, the only
Yeah,
thing that'll be like really different is notation. That's for
yeah.
sure. Like that's just a given.
Yeah, notation and how they implement it and stuff like that would obviously be very much different because that's, again, very subjective, right?
The thing is, because physics is like it's a subject that is written in the language of math.
Sorry, I really thought you were going to stop at physics as a subject. So I'm like, what?
No. Physics is a subject that's written in the language of math.
Mhm.
And so let's say aliens, they notice that gravity is an accelerating force. Well, that's kind of like a double positive, you know.
Yeah, I mean, it is a force. It's not an accelerator.
It is a force.
It's just a
But no,
force.
do you know how humans figured out that gravity accelerates things?
No, but I have the feeling that you're going to share it.
Yes, I am.
Okay,
So,
let's go.
so like imagine this. You throw a rock down from like the first floor of like a building. You don't really notice that it accelerates that much. It kind of just like falls.
Mhm.
But like to the naked eye, you can't really like tell that like, oh, it's going like significantly faster than it was when I dropped it.
Mhm.
Or, you know, whatever. But what Galileo did back in the day to like prove that like gravity is like an acceleration type deal, and that it wait, Galileo was after Newton. Yeah, definitely.
Yeah.
So yeah, what I just said like previously was probably all BS.
What?
But Galileo,
What? Wait, all of this Galileo stuff was all BS?
no, that's right. Okay,
Oh,
so Galileo,
okay.
he took like a piece of wood and then had a marble, and he put the wood on an angle, and then what he would do is he would like time the marble going down the piece of wood, and he noticed that the time it takes to go down the first half was longer than the time it takes to go down the second half. And then he would like decrease the angle, and then he would measure like shorter distance intervals, and then compared the times it took to travel each interval. And then he noticed that the velocity was increasing at a linear rate, which means that the position was increasing at a quadratic rate.
Mhm.
And then he's like, yeah, boom, gravity explained.
That's pretty cool. That's a really cool way to think about it.
Yeah, and that applies
Yeah.
to like projectiles, in the sense that it's like a perfect parabola. Like every time you throw something in the air, it's a perfect parabola, you know, excluding air resistance and wind and all that.
Yeah, and that's exactly why I'm saying I think it's very possible for another civilization to discover it. I mean, not that we would have, but I mean, if Galileo could in such a simple experiment, I'm pretty sure that other people can also discover gravity. We haven't actually spoken about how they would discover the physics of it all. We've just spoken about the math mainly.
That's right.
As you said, you kind of transitioned into it by starting to talk about how, you know, physics is written in math, and how if given enough time to play around with math and understand it, I guess you can start applying it to real life situations, you know, and maybe that's where they came up with the idea of physics.
What do you think the first application of math is in physics?
That's a fantastic question.
I think it's definitely like speed, like velocity.
To be honest, I just think the simplest one is speed equals distance over time, right? That's
Yeah.
I think the simplest equation that we've learned. God only knows how young. Like it's very simple, and it's both a math and physics. The first thing that's applied in physics, right?
Yeah.
But do you think that's the first application though?
Like what's easier than
No, but
finding
just because something
velocity.
is easier doesn't necessarily mean that it was the first one. Because there are a lot of times when like the first one is really stupidly difficult, and then years after they find easier ways to do it and easier ones. You know?
Like, what do you think?
You think no, no. Because okay, when was okay, I don't even know. Physics was not really invented. It was more I mean this again goes on the question, was math invented or discovered, right? So, I guess physics
Hmm.
invented or discovered. When was it? When was it either invented or discovered? Would you
I
even know?
just had an idea
What?
or a thought.
Okay.
Like, how insane is Pythagoras' theorem?
I mean, we have spoken about this. It's really cool.
Literally explains like absolutely everything.
Yeah, it's really cool. It is
Yeah.
very impressive too.
And literally, you see it everywhere. Calculus is all Pythagoras' theorem. In physics, linear algebra, everything you do is just okay. Now you add it in quadrature, and then boom, it's all
Pythagorean is really
diagonals,
useful,
man.
yeah.
Anyways, coming back to our idea of where did physics start? Like
Mhm.
physics, it didn't really start anywhere. Like it just kind of, it's just
No, not anywhere. I'm like, when do you think it? Like, when do you think
no,
it
it didn't.
started?
It didn't
Like,
start at a particular time. Like it just,
no, but when do you think
it
humans discovered it? I'm saying.
bro, I'm telling you, it wasn't it wasn't like a specific time that it started. People just started like things just started brewing, and then over time it got collected
Yeah. So
into
exactly.
like,
So my question is, when did they start brewing? Like, when did they
man,
start thinking about physics?
how am I
As
supposed
I
to
mean,
know that?
obviously, no, you wouldn't know. The main question was, hey, let's search it up on Google. But like the
That
main idea was,
no.
you know, how far away was the physics discovering from the math discovering? Like that would be a really cool question, right? To find out like how
Uh
long I guess it took them to see the applications,
yeah. Yeah,
right?
that's
And
right.
also what what do you think physics was in the beginning? Do you think in the beginning when physics just started it was written in the language of math, or do you
Yeah.
think it evolved to be written in the language of math?
No. I think it was always written in math. Well,
Okay.
at first like you had to describe your situations with like words, but when it got to actually finding answers and like how are you going to describe velocity as distance over time? That's just division. Like it's already math, you
Mhm.
know.
That's true.
So
That's actually true.
yeah,
I guess if you're talking about, the simplest, yeah, that would be math. But do you think
like it's
speed
already
equals
math.
distance over time was like the first thing to be discovered? Because I, I,
I
I have
think
a
so.
feeling like it wasn't as simple as we think it was to discover, speed equals distance over time. Like
Yeah,
it's very
probably not.
easy to think about it now, but I'm
Yeah.
saying like
Actually,
back then,
the very first thing would be like measuring distances between like two trees or something. Like you start measuring the relative distance between like your campsite and the nest of a bear. Like it's 500 paces. I don't know. You start measuring distances, and then you say like, okay, well, how long does it take to get to the river? Because I need water. So then you start measuring like, okay, the river's 1,000 paces away, and it takes me like, I don't know, a quarter of a cycle of the sun. Then you start, well, you start doing the distance over time
quarter of
thing.
a cycle of
I don't know.
the
You
sun.
don't have a clock, bro. You don't have a clock, so you're just looking at the sky. So in that case, you start piecing things together, and it's like, okay, well, if I'm going at at that rate of position changing, then it'll take me 2/4 of a sun quarter, whatever in the sky, to go there and back. And then now you're calculating time based on velocity and
Yeah, but again, you would
distance.
have to know that speed equals distance over time to do that
Well, no,
calculation.
not even. Think about it, Ray. Think about it. You say, okay, it takes me 20 minutes to go that far. Well, to go there and back, it'll take me 40 minutes. Like, that's just.
Oh, that's what you mean. Well, okay,
Yeah.
again, okay. You do make a very strong point. I guess that does make sense. Probably one
Yeah.
of the first ones. But do you think it was the first one?
Yeah, I do. Like
Okay.
like to be honest, like what else? What did we learn in physics? Like
What about, I mean, okay, not that this is a podcast to talk about, what about chemistry and biology and stuff? What do you think
what are
about
you
that?
talking about? As if they were studying atoms back then.
Well, not, okay, I guess that's true as well. No, but biology, though, okay, not necessarily like, microbiology, but maybe like
Okay, wait.
talking
If you
about
consider like boiling water chemistry,
chemistry.
then that's before physics, I think.
Well, again, I don't really know if they would. I guess they would, yeah, just make a fire and just put water on
Yeah.
top. Sure, why not?
Yeah.
That would technically be chemistry.
Yeah. Anyways.
Yeah, I guess that would.
We've gotten pretty far away from alien math.
Yeah, we've gone pretty far. I mean, well, technically, we're still talking about
Yeah.
how civilizations would discover these things, so we're
Yeah,
not
that's
that far
right.
away from it,
That's right.
But we have passed the 30 mark,
Yeah.
right? So what we can do is we can have a follow-up episode on this, which we will.
Just
we
like every single other episode we make, we're like, yeah, we'll do
yeah,
a
because
second
again,
one.
I mean, in all of these podcasts, again, as you said in the beginning, right? We're just talking about this stuff.
Yeah.
And there's so much more stuff to talk about. Like, we can just keep
Yeah.
talking, And because podcasts don't really have a limit to how many you can make, why not
Yeah,
just make
that's right.
part twos of literally everything?
At the same time, like we should definitely write stuff down before we do a podcast.
Yeah,
Like
maybe.
then I start saying
maybe.
some stupid shit about how Galileo invented math.
Yeah, maybe that. I mean, there probably should be a fact checker that we have.
Yeah, that was no. Don't get me wrong. That was definitely right. Like the thing about the
about
plank of
Galileo.
wood. That was definitely right.
Okay.
Yeah.
Okay, because I
Anyways.
liked how you said all of that was BS.
No.
And I'm like, what?
Nah. Like the thing I said about gravity seemed like it was not accelerating. Like that was probably a lie.
Oh, okay,
But-
okay.
Yeah, we're getting pretty far into this. Should we just cut it off here?
Okay, so we're gonna cut it off here.
Yeah, so
yeah.
if you're listening to this right now, make sure to follow us on whatever you're listening on. We would appreciate it. As well as tuning in to next week's episode or whenever it comes out.
Okay, so we're at about 34 minutes, so we're just gonna end it here. We pretty much talked about how civilizations in general would come up with ideas for mathematics, discovering it again. And we haven't even actually spoken about that, if math is invented or discovered. That's a whole conversation.
Yeah, true.
That's a whole new conversation. Anyways, thank you everyone for joining us on this podcast.
So we will see you next time. I'm your host, Parker.
And I'm Ray, and we will see you soon.
See ya.